This is the video related to the quantum numbers. There are 4 quantum numbers in our chemistry, that is N, L, M and S. N is the first principal quantum number, L is the azimuthal or angular quantum number, M is the magnetic quantum number and S is the spin quantum number. We'll study all the quantum numbers in detail. First is the principal quantum number, that is N. The value of N can be any positive integer. N cannot be equal to 0 but can be any integer. For example, N can be 1, 2, 3, 4, 5 and so on. Basically, N principal quantum number tells us about the shell or the orbit in which the electron resides. N is equal to 1 means first shell K shell, N is equal to 2 means second shell N shell, N is equal to 3 means third shell M shell, 4 N shell and so on. Basically, this quantum numbers tells us about the size of the orbital. As the value of N increases, size of the orbital will also go on increasing, and same for the energy, because the energy of the orbital which is nearest to the nucleus is the less, and as we move away from the nucleus, energy of the orbital will goes on increasing. Basically, the quantum numbers describe the address of the electron, and N describes the shell, main shell of the electron. Okay, now second quantum number is L. L is the azimuthal or angular quantum number. You can say anything. L describes us about the shape of the orbital. The orbital will be of which shape? Basically, orbital is 3D in space, 3-dimensional in space. The shape of the orbital can be any. It can be cube, it can be square, it can be any shape. But the shape of the orbital will be described by the L. Now, the value of L can start from 0, 0, 1, 2, 3, 4 and so on. Now, we have two things, name of the orbital and shape of the orbital. Name of the orbital and shape of the orbital. Corresponding to the value 0 of L, the name of the orbital will be S. For 1, the name of the orbital will be P. For 2, the name of the orbital will be D. For 3, it will be F. For 4, it will be G and so on. Now the shapes. The shape of S orbital is spherical. The shape of P orbital is dumbbell. The shape of D orbital is double dumbbell. The shape of F orbital is complicated. And the shape of G orbital is 8-fold structure, 8-fold complicated structure. Now, the value of L, the range of L is 0 to n minus 1. Basically, the value of L depends upon N, principal quantum number. N is the N is the principal quantum number which gives us the shell of the electron. The shell has subshell in it. So, the shell has a subshell in it. Shell is given by L and subshell is given by L. Okay, the value of L depends upon N. Now, according to this formula, if the value of N is 1, the value of L will be 0. This is written as, this is the value of N and this is the name of orbital which is given by L, which is given by L. For L0, the name was S. So, this is 1 S. For n is equal to 2, the value of L will be 0 to n minus 1, 0 to 2 minus 1, 0 to 2 minus 1 is 1, 0 to 1, 0 and 1. Corresponding to 0, the name of the orbital will be S. So, it is 2 S respectively, and for 1, the name of the orbital will be P, 2P. This is written as 2P. For 3, the values of N will be 3 minus 1, 2. From 0 to 3 minus 1, 2. That is 0, 1, 2. You can write 3, 3, 3. Corresponding to 0, 3S. Corresponding to 1, 3P. Corresponding to 2, 3D. Now, next is 4. corresponding to 4, the values of L will be 4 minus 1 3 from 0 to 3, 0 1 2 3, 4 S, 4 P, 4 D and 4 F. These are the values of L. This is the formula. Trick. Number of subshells in a shell. In any shell, how many subshells will be there? This is equal to shell number or orbit number. I am explaining you it as, if the value of n is 1, orbital is also 1, that is 1s. If the value of n is 2, orbitals are 2, 2s and 2p. For 3, the orbitals are 3, 3s, 3p, 3d. For 4, the number of orbitals are 4, 4s, 4p, 4d, 4f. Okay. Now, there is a formula related to the azimuthal quantum number. Orbital angular momentum of an electron is h upon 2 pi, where h is Planck's constant, h upon 2 pi under root L plus 1, where L is the azimuthal or angular quantum number. Now, what is the question here? Find orbital angular momentum of an electron in 3p subshell. Orbital angular momentum, we have to calculate orbital angular momentum of an electron which resides in the 3p subshell. 3 here is value of n and p is calculated from the value of L. For p, the value of L was 1. The value of L was 1 for P. L is equal to 0 for S, L is equal to 1 for P, L is equal to 2 for D and L is equal to 3 for F. So, the value of L will be 1 here. We will put it here, h upon 2 pi as it is, 1 plus 1, it will be this. Okay. Questions can be asked from here. Now, L basically gives us the shell and the size of orbital. L gives us the subshells and shape of the orbital, spherical, dumbbell, complicated, eightfold and so on. M, next quantum number, magnetic quantum number, tells us the orbital. How many orbitals will be there and the orientation of the orbitals. About x-axis, about y-axis, about z-axis, in between the axis or lying along the axis. Now, the third quantum number is M, magnetic quantum number. It will give exact orientation of the orbital. Now, it will tell us one thing more, that how many orbitals will be in a given subshell. How many orbitals will be in a given subshell. The range of M will be minus L to plus L. Basically, these quantum numbers dependent upon one another. L depends upon N, M depends upon L. Basically, L depends upon N. Directly or indirectly, you can say anything. Now, the values of L are written here and the values of M will be written here. For the value of L is equal to 0, the range of M will be minus 0 to plus 0, that is simply 0. For the value of L, M will be minus 1 to plus 1, minus 1, comma 0, comma plus 1. The values which are in between the negative and positive values will be considered here. For L is equal to 2, the value of M will be from minus 2 to plus 2. Minus 2, minus 1, 0, plus 1 and plus 2. For L is equal to 3, the value of M will be minus 3 to plus 3. That is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. This is written as name of orbital, which we have done in the second quantum number. For L is equal to 0, name of orbital was S. For 1, it was P. For 2, D, 3, F. Now, S has one orbital. This is the number of orbital. For L is equal to 0, the name of the orbital was S and the counting of orbital is 1. 0. S has one orbital. For P, number of orbitals are 1, 2 and 3. Their value can be anything. It can be 0, 2. P has 3 orbitals, 1, 2 and 3. D can have 1, 2, 3, 4, 5 orbitals. F can be F can have 1, 2, 3, 4, 5, 6, 7 orbitals. Now the orbitals are denoted as the square box, or you can draw it as circular shape. S has one orbital from here. You can write it as here, or write it as circular shape or square shape. P has 3 orbitals, D has 5 orbitals, 5 sections basically, and F has 7 orbitals. Now this is again the formula. Number of orbital in a given subshell is 2l plus 1. For example, number of orbitals in any subshell, it will be 2l plus 1. The value of L will be put here and the value can be calculated. For L is equal to 0, that is for S. For S orbital, the number of orbitals will be, for S orbital the value of L is 0, 2 into 0 plus 1. This will be 0 and 1. The number of orbital here is 1. Okay. Now this is the table describing us the relation of N, L and M. N, L and M. First column is of values of N, second is of L and third is of M. N can never be 0. So here will be no value of L and M. The range of L was 0 to N minus 1. The range of M was minus L to plus L. For N is equal to 1. The value of L will be 1 minus 1, 0. It will be only 0. M will be minus 0 to plus 0, only 0. So the name of the orbital will be 1 from the value of N and S from the value of 0. L is equal to 0 is equal to S. So it will be 1s. The orbitals are 1 for S. So one orbital is drawn here. Now for N is equal to 2, the values of L are 0 to 2 minus 1, 1. Two values, 0 and 1. 0 and 1. For 0, the name of the orbital is S, and for 1, the name of the orbital is P. Corresponding to 0, it will be written as 2s, 2p. 2s, 2p. These are written here as values of M. Minus 1 to plus 1, that is minus 1, 0 plus 1. For 0, it is 2s, minus 1 and plus 1. Negative value we will not consider here. For positive one, it is written as 2p. For S, there is one orbital, so 1 is drawn. For P, here are 3 orbitals, so 3 are drawn. Similarly, for 3, N is equal to 3. Values of L will be 0, 1 and 2. 3 minus 1, 2. 0, 1 and 2. Correspondingly, the values of L will be 0, S, 1, P, 2, D. It will be 3, S, 3, P, 3, D. 3s, 3p, 3d. You can cut it. You can skip this. For S, orbital is 1, so 1 orbital is drawn here. For P, 3 orbitals are there, so 3 orbitals are drawn here. And for D, 5 orbitals are there, so 5 orbitals are drawn here. Now, next value of N is 4. Correspondingly, the values of L will be 0 to 4 minus 1, 3. 0, 1, 2, 3. S, P, D, F. It will be 4s, 4p, 4d, 4f. For S, the number of orbitals are 1, so 1 is drawn here. For P, 3, D, 5 and F, 7. Now the last quantum number is spin quantum number. It is written as S. Every electron rotates about its own axis. Every electron rotates about its own axis. It can rotate in clockwise direction or anti-clockwise direction. So there are two spins of the electrons, plus half or minus half. In any orbital, if 2 electrons are there, their spin will be opposite. One will be rotating anti-clockwise or clockwise. You can say anything. It can be clockwise or anti-clockwise. If this is clockwise, this will be anti, and if this is anti-clockwise, this will be clockwise, just opposite to each other. So there are two spins of the electrons, plus half and minus half. This was all about the quantum numbers.